So you're taking physics. First off, that's awesome. I know it's scary and physics is hard, but hopefully we can help you out a little bit today. If you're here, you're probably learning about kinematics and projectile motion. They're not as hard as they seem. And you've probably gotten the equations at this point, but hopefully today we can talk about some tips and tricks to help you when you're solving those problems on your homework or on your tests, so that way they're not so daunting and you can get the right answers a little bit easier. So let's get straight into it. Tip number 1. Identify your knowns and your unknowns. In kinematic equations, there's 5 variables that are important: velocity initial, velocity final, acceleration, distance, and time. There are 5 equations that each have 4 variables, and so if you can identify 3 things that you do know, you should be able to solve for the 4th that you want. Knowing what you know and what you want is really important. So make sure you write those down on your paper when you first start your problem. Let's say you know velocity initial, you know velocity final, you know the time, but you want to know the distance. Write down those things. Write down a question mark next to distance, and then from there you're able to identify what you're supposed to do. Tip number 2, split your problem into its x and y components. When things move on diagonals, they're really hard to solve. When you have a problem that goes up and down and a problem that goes side to side, the math suddenly becomes a lot easier. To see an example of where this might be helpful, let's watch a quick video. Splitting a problem into its horizontal and vertical parts is important in problems where there is both horizontal and vertical motion at the same time, like so. Let's talk about how we can solve that problem. So in the case of a ball moving in an arc, splitting it into x and y is extremely beneficial. First off, your velocity in the x direction shouldn't change because there's no acceleration. As the ball travels through the air, the only force that's acting on it is gravity, and so it only accelerates in the y direction. The x velocity should stay constant, and so velocity initial in the x and velocity final in the x should be the same value. Furthermore, acceleration is 0. In the y direction of this problem, our vertical velocity changes, but at a known rate of negative 9.8 meters per second squared, which is acceleration due to gravity. The vertical direction also has the known of velocity initial, but because it's changing, you don't know velocity final quite yet. However, a key piece of information about these 2 equations is that they're going to take the same amount of time. And so if you can solve t for one, you can then use that t in the other to get whatever information you want. And that'll change based upon the problem. Tip number 3, use energy to check if your solution is correct. Just because you can get something using kinematics doesn't mean that you can't get it using energy, or that energy can't be helpful to determine whether or not you were actually right. Now let's talk about a simple problem where we can use energy to make sure we got the correct answer. A simple toss up and down with the ball will allow us to compare the kinetic energy right at the beginning of the launch and the gravitational potential energy at its peak. Now, in this case, at the top, since there's no motion, the only energy there is gravitational potential energy. At the bottom of the launch, there's no gravitational potential energy, there's only kinetic right as soon as you throw the ball up into the air. That means that if you set the kinetic energy at the base of the launch equal to the gravitational potential energy at the top of the ball's peak in its motion, they should be equal because energy is always conserved. Doing things like this, whether it be with springs or with gravity or with motion, you should be able to identify some easy points along the projectile's path and make sure that energy is conserved. It should be equal at all points during its path. Some equations can be solved entirely using energy, but it's definitely helpful to use energy to check to make sure your answer was correct. And with that, I'll leave you. Hopefully these tips were helpful for your problem-solving strategies next time you work on a homework problem or a test using kinematics and projectile motion in physics.